Okay, so let's take a look at this first problem where we have demands that for each increase of $1, the demand decreases by 8,000 units. So we know that the slope of this thing is going to be negative 8,000. So we have negative 8,000x, where x represents the price. And we're going to end up with plus 180,000. And the way that we know that is that if we reduce the price all the way to 0, that's 10 reductions of $1 each. That means that would be 10 increases of 8,000, which would bring us up to 100,000 plus 80,000. So that means that our intercept would be 180,000. So this is our demand here. And again, it's that negative 8,000 times x, where x is the price in dollars, plus 180,000. Okay, so then we want to figure out, well, how should we maximize our revenues? Our revenues are going to be equal to the number of units we sell, which we already know is equal to this, negative 8,000x plus 180,000. And we have to multiply that by how much we'll earn for each unit, which again is x. So that's going to give us negative 8,000x squared plus 180,000x will be equal to our profit. So we know that if we graph this, we'd get something that looked like this. And we want to figure out, well, what's going to give us our revenues right here? Well, we know it's going to be halfway between where this thing crosses the 2 points at which it crosses the x-axis. So if we set this equal to 0, we're going to get negative x times 8,000x minus 180,000. So we know we're going to get one value. We're going to set this equal to 0, which means that the solutions are either x is equal to 0 or whatever sets a value of x sets this equal to 0, which would be x is equal to 22.5. So that means that the x value of this point is going to be 11.25, which is just half of what we got when we divided 22.5 by 2. And so when we now go look at, well, what's going to be the point where we get our maximum revenues? Well, we need to figure out what would be the y value at that same point. And what we see is that if we do the calculations, we're going to get a y value of 1,012,500. And that's just by plugging in 11.25 into our revenue expression here. Okay. So we also have our cost to take into account, which we haven't already taken into account. So we need to figure out, well, what's going to be our price that we set to maximize our profit, which is equal to revenue minus cost. So we would take our revenues, which would be negative 8,000 x squared plus 180,000x, and we would subtract from that our cost, which would be 150,000 plus 5.5 per unit. Well, the number of units we already know is equal to negative 8,000 x plus 180,000. And so this now, when we work it out, is going to give us our profits. So when we graph this, you're going to find that you're going to get your x value is going to be equal to 14. That's going to be the vertex for this particular graph. And we're going to end up with a profit of $428,000. Okay. Now, there's a couple ways to think about simplifying this, but what you end up with is negative 8,000 x squared plus 224,000x minus 1,140,000. Okay, so you'll see when you work this through that you should come up with that. Okay, Let's solve this next for f of x equals 0. So we're going to use the quadratic formula. So we have a is equal to 2, b is equal to negative 5, c is equal to negative 10. So we have negative b plus or minus the square root of b squared. So we have negative 5 squared minus 4 times a times c. And all of that is over 2 times a. So what we end up with is positive 5 plus or minus the square root of, we're going to get 25 plus 4 times 2 times 10, which is equal to 80. So we end up with the square root of 105, and all of that is over 4. Okay, so 5 plus or minus the square root of 105. And 105 is equal to 3 times 5 times 7, so we cannot factor a perfect square out of that. Okay, so let's go on. Next thing we have to figure out, well, what are the coordinates of the vertex? So we already know that our vertex is equal to negative b over 2a, which is going to give us 5 over 4 is equal to 1.25. When we plug that into our equation of 2x squared minus 5x minus 10, we're going to get 2 times 5 fourths squared minus 5 times 5 fourths minus 10. This will give us 25 over 16, and so this will give us 50 over 16 when we double it, minus 25 over 4, minus, we'll call this, well, let's say we're going to call this 160 over 16. This is going to change to minus 100 over 16. So we're going to end up with negative 50 minus negative 210 over 16. And that equals, I think, 13 something, negative 13 something. Okay, the next one asks us to figure out what is f of root 3 plus 1. So we have to plug root 3 plus 1 into our equation. So we get 2 times root 3 plus 1 squared minus 5 times root 3 plus 1 minus 10. This is going to give us 2 times, when we square this, we're going to get root 3 times root 3, or 3, plus 1, plus 1 times root 3, plus another 1 times root 3, so plus 2 root 3, minus 5 root 3, minus 5, minus 10. This is going to give us 8 plus 4 root 3, minus 5 root 3, minus 15, and we're going to end up with a negative root 3 minus 7, which is about negative 8.73. Okay. Moving right along. So basically, we're saying that there's some value r, and when we multiply our original value times r, we're going to get how much our investment is worth in 2016. In 2017 would be r squared, 2018 would be r cubed, 2019 r to the fourth, 2020 would be r to the fifth. So 5,000 times r to the fifth is going to equal our value in 2020. So 5,000 r to the fifth equals 7,000, which is to say that r to the fifth is equal to 1.4. R is equal to 1.4 to the 1 over 5, or the fifth root of 1.4, which is about equal to 1.0696, which means that our investment is increasing at a rate of approximately 6.96% per year. Okay. Next page. Okay. In order for this thing to have two real solutions, our discriminant, which in our negative b plus or minus the square root of b squared minus 4ac over 2a, our discriminant is b squared minus 4ac. And the reason is that we need this thing to be positive in order for this to have two real solutions. This has to be 0 for this to have one real solution, and if this is negative, we have no real solutions. So we need b squared minus 4ac for the first one to be greater than 0, which means that we need 36 minus 4 times a times c to be greater than 0, which means that we need 36 minus 12a to be greater than 0, which means 36 has to be greater than 12a, and so that means that a has to be, so 3 has to be greater than a, so a has to be less than 3. In this case, if a is equal to 3, we end up with b squared minus 4ac equals 0, and we get just one solution. And what that means graphically is that our vertex is right on the x-axis, which means that we only have one value of x that sets the function equal to 0. No real solutions means that a has to be greater than 3, because that would give us value under the square root that is negative, so there's no real number that would make that true. For this one, not only do we need it to be positive, we need it to be equal to a perfect square. So we need, in other words, that 36 minus 12a has to be equal to a perfect square, which means that it could be equal to 25, or it could be equal to 16, or it could be equal to 9, or it could be equal to 4, or it could be equal to 1. And so, therefore, or in fact, we could, if a is negative, we could end up with values greater than 36. So, for example, if 36 minus 12a is equal to 49, then we would get that a has to be equal to, we'd get negative 12a is equal to 13, and a would be equal to negative 13 over 12. So there are actually an infinite number of solutions. So as long as 36 minus 12a is equal to a perfect square, then we'll get a rational solution to this. Okay. Next page here. Okay, we are factoring these. So the first one, we're going to get x. We need two numbers that multiply to negative 48 and add to negative 2. So that's going to give us x minus 8, x plus 6. Here, we're going to use the method. First, we factor out the x to get x times 2x squared minus plus 5x minus 12. So now we need two numbers that multiply to 2 times negative 12 and negative 24 and add up to positive 5. So those two numbers would be positive 8, negative 3. So we break this 2x squared minus 3x plus 8x minus 12. And then we factor that by groups to get 2x minus 3, x times 2x minus 3 plus 4 times 2x minus 3. So we end up with the final factorization of x from the first line, so x times x plus 4 times 2x minus 3 is the final factorization. Okay, the next one, we have a perfect square, and so this is equal to 3x squared squared. This is equal to 2y squared. So if this middle term is equal to double the product of these two, or negative double the product of these two, we have a perfect squared trinomial. And that, in fact, is the case. So we end up with our factorization of 3x squared minus 2y squared. And you'll see that if we work this through, we're going to get 3x squared squared to get our first term, negative 2y squared, the whole thing to get this, and then 3x squared minus 2y, and another 3x squared minus 2y to get our middle term. Okay, here we have difference of perfect squares. So we have a squared minus b squared equals a minus b times a plus b. And in this case, a is equal to 4x minus y, b is equal to 2x plus 3. So we're going to get here that we have 4x minus y plus 2x plus 3 times 4x 4x minus y minus 2x plus 3. And when we simplify, we end up with 6x. This should be 3y here. We get 6x plus 2y times here 2x. And then we have hard to read this, but negative y plus 3y, so we have plus 3y here. And that's our final factorization. We could continue to factor out actually a 2 from here and a 2 from here, but that's fine. We'll skip that for now. Okay, moving right along. Okay, we want to do some simplifying here, and in this case what we want to do is we want to multiply by what's called the conjugate of the denominator, which is root 10 plus root 5 over root 10 plus root 5. So because we're just multiplying by 1, we're not changing the value here, but what we're going to do is, because of the difference of perfect squares, a minus b times a plus b gives us a squared minus b squared. So our denominator is just going to end up being root 10 squared minus root 5 squared, or just 10 minus 5, or 5. Meanwhile, up top, we're going to get root 5 times root 10, which is root 50, plus root 5 times root 5, which is just going to be 5. So we have this. And this we can say is equal to 5 root 2, because this root 50 is equal to root 25 times root 2, plus 5 over 5, and that's just going to be equal to root 2 plus 1. All right, this one, bunch of fractions to deal with. So first let's get the numerator to have the same denominator. So we're going to multiply, we're going to have the same denominator of x times y here. So we're going to get 4y over xy plus 10x over xy. Meanwhile, down here we end up with 2y plus 5x over 2xy. Okay, so a couple things that we can see here is that these two are going to cancel out to leave us with just a 2 up here over xy, and down here just a 1 over 2xy. We divide these two, the xy, out, and we end up with just 2 over 1 over 1 over 2. And so what this ends up being is just equal to 4. Okay. Moving right along. Okay, so this next one. So this one gets a little complicated. So we want the intersection of these 2 points, of these 2 curves. We want the x value of one of the points of intersection to be 5. So when we're dealing with intersections, we do subtraction. We say ax squared plus x minus 10 minus 2x squared plus 3x plus 5. So we end up with a minus 2 times x squared minus 2x and then minus 15. And we want to find out what value of x will set this thing equal to 0. Or rather, we want one of the values of a to be such that this thing, when x is 5, this will be equal to 0. Okay, so we're going to use the quadratic formula, and we're going to get negative b, or 2, plus or minus the square root of b squared, which is negative 2 squared, or 4, minus 4 times a, which is in this case a minus 2, times c, which is negative 15, all over 2a, or 2 times a minus 2. We want that to be equal to 5. Okay, so let's simplify a little bit here. And what we'll do is we'll get 2 plus or minus, and inside here we're going to end up with this whole thing becomes 4 minus, or rather plus 60, which is 4 times negative 15, times a minus 2, and this is over 2a minus 4. And again, that's equal to 5. And so this ends up giving us 2 plus or minus the square root of, and when we end up combining everything here, we're going to get 4 plus 60 times negative 2. So we end up with negative 116, 60a minus 116 over 2a minus 4 is equal to 5. So we'll multiply both sides by 2a minus 4 to get 2 plus or minus the square root of 60a minus 116 is equal to 5 times 2a minus 4, or 10a minus 20. We'll add the negative 2 to both sides, and we get square root of 60a minus 16 is equal to 10a, and that's minus 22. Now we're going to square both sides. Sorry, this should have an a in it. Oh, it does have an a. Okay, we're going to square both sides to get that 60a minus 16 is equal to this thing squared, 10a minus 22, which is 100, a squared minus 440a plus 484. Okay, so then we're going to subtract 60a minus 116 from both sides, and we're going to end up with 100a squared minus 500a, and plus 600 equals 0. We can multiply it or divide everything through by 100 to get a squared minus 5a plus 6 equals 0, and that factors to a minus 3 times a minus 2, so a could be either equal to 2 or to 3 to get an x value of 5. Okay. Next problem here. Okay, what would have to be true for these to have any points of intersection? And that means that our discriminant has to be equal to 0. And so going back to our discriminant, which we found turned out to be equal to 60a minus 116, that has to be greater than 0. So 60a has to be greater than 116, so a has to be greater than 116 over 60. Okay, positive number 1 is greater than its own reciprocal. What is that number? I'm sorry, this should be equal to. Oh, that's terrible. Equal to. So we get a positive number, x, is 1 greater than, so it equals its own reciprocal, plus 1. And that gives us that x minus 1 over x minus 1 equals 0. Multiply everything through by x to get x squared minus 1 minus x equals 0, or x squared minus x minus 1 equals 0. Using the quadratic formula, we're going to get negative b, or 1, plus or minus the square root of b squared, which is 1, minus 4 times 1 times negative 1 all over 2a, or 2. We end up with 1 plus or minus the square root of 5 over 2. Okay. The line G has equation y equals 2x plus b, x squared, y equals x squared, and G intersect at exactly one point. What's the value of b? Okay, the intersection again, x squared minus 2x plus b, and we know that we want this to have just one solution, which means that the discriminant has to be equal to 0, which means that b squared minus 4ac has to be equal to 0, which means in this case negative 2 squared minus 4 times 1 times b has to be equal to 0, or 4 minus 4b has to equal 0, so 4 equals 4b. b therefore would have to be equal to 1. Okay. Finally, cylindrical can with top lid must contain 500 centimeters cubed of liquid. What dimensions will minimize the cost of metal? Okay, a couple things here. So first of all, we know that the V is equal to 500 is equal to pi r squared h, which is the volume formula for a cylinder. What we're trying to minimize here is 2 pi r squared plus 2 pi r h. Okay, so the easiest thing to do will be to express h in terms of everything else. So we get h is equal to 500 over pi r squared. And substituting that in here to the surface area formula, we get 2 pi r squared plus 2 pi r times 500 over pi r squared. And that gives us 2 pi r squared plus 1,000 pi r over pi r squared. Okay, so then when we simplify, we get 2 pi r squared plus 1,000 over r. Okay, then what we need to do is we go and enter that into Desmos or whatever graphing app you want to use. Again, remember to replace the R with the X for Desmos because it won't understand if you just put in an R. Okay, so when you graph that, and the main thing will be making sure that you get the scale of your coordinate plane correct so you can see everything. But when you do graph it, you'll get something that looks roughly like this. Very roughly like that. And your point that you're interested in is the point here, which is the minimum, and that has coordinates 4.30 and 348.7, which means that we would set our radius equal to 4.3, and that would yield a total surface area of 348 square centimeters, which would be the lowest surface area for a cylinder that contains 500 centimeters cubed of liquid. All right, moving right along. Okay, find all solutions for this. So what we want to do is we're going to end up multiplying first by x minus 1 and then by x minus 2, which is the equivalent to multiplying 2x minus 5 times x minus 1, and that would be equal to x plus 1 times x minus 2, which means we'll get 2x squared minus 7x plus 5 is equal to x squared minus x minus 2, subtracting x squared minus 6x plus 7. And this is not factorable, and so we will use the quadratic formula, and that will give us negative b, so positive 6 plus or minus the square root of b squared, which is 36, minus 4 times a times c, all over 2 times a, so we get 6 plus or minus the square root of 36 minus 28, or 8, over 2, which gives us 6 plus or minus 2 root 2 over 2, which is equal to 3 plus or minus the square root of 2. Those are our two solutions. Okay.